The fundamental theorem of calculus. So for the past few days, we've been looking at the antiderivative and the definite integral, or the area under the curve, and we've been kind of alluding to the fact that those two things are related, and in fact, they are very closely related. So we're going to connect them through the fundamental theorem of calculus, and we can do it a little bit more formally in a different video, but for now, we're just going to look at the big ideas here. So in math, every operation has an opposite. So multiplication and division are opposite, squares and square roots are opposite, exponents and logs. In calculus, we have differentiating or finding slope, and the opposite of that is going to be anti-differentiating, which is related to area under a curve. So finding slope and finding area are opposite operations in calculus. So there's the fundamental theorem of calculus, and there's two parts to it. And the first part, which we're going to call just part one, so part one is basically saying that the integral and the derivative are opposite operations. They essentially undo each other. Okay, so if we take a look at what it says here, we start with our f of x, we integrate it, we're going to end up with our big F. If we differentiate big F, we're going to get back to what we started with, our little f. Okay, so when we differentiate and integrate together, we're going to they will undo each other, and we'll start back where we will end up with where we started. Okay, so the integral and derivatives are opposites. The second part of the fundamental theorem of calculus is going to be relating the antiderivative to the area. So this is part two. And what part two is saying is that if I want to find the area under the curve, okay, so this is my definite integral, the area under the curve, it can be found using an antiderivative function, or big F. And it can be found by looking at the displacement on the antiderivative from a to b, or f of b minus f of a. F of b is the end, f of a is the start. So that displacement, or the change in big F, this is the displacement in the antiderivative, is equal to the area under the curve. Okay, those two things are equivalent to each other. So that's part two. So part one is that integrals and derivatives are opposite. Part two is that the area under the curve and the displacement on the antiderivative represent the same thing. Okay, so these are the two parts of the fundamental theorem of calculus. Now, we could take a little bit closer look at part one, and we can look at the fact that if I take the integral, so if I start with the integral piece here, okay, if I anti-differentiate that, I'm going to end up with big F of t from a to x. So this line represents my bounds. And when I do that, I'm going to find the displacement, big F of x minus big F of at some fixed point A. So that fixed point A makes this a constant term. So this is like our plus c in our indefinite integral. If I take that and I differentiate this, so I take that expression and I differentiate this, well, the derivative of big F is just going to generate my f of x again. And then the derivative of the plus c is just going to give us plus 0. So if I undo my integral, I'm going to get back to my original f of x. Okay, so that's kind of an informal way of looking at it, is connecting the two, part one and part two, together. Now, we can take a little bit deeper look at this in another video, and that's looking more formally at connecting the fundamental theorem of calculus, two parts of the fundamental theorem of calculus.